Johan, to you, it's the planetary boundaries. When that became got into the public sector, into the lexicon, people didn't really understand what it was, and you brilliantly defined that. And anybody who cares about planet Earth should know about these, should read up on the planetary boundaries, because it really is telling us what we can and what we cannot do. There's no negotiation. And so my question to you is, as director of the co-director of the Potsdam Climate Institute, you have recently put forward into the public a new study. Can you tell us the most current scientific data and information on the Arctic and the Arctic sea ice?
Yeah, thanks, Sally, and Prince Albert, and then dear colleagues, friends. So just to mention briefly that the planetary boundary framework does not come just out of the blue. It was a natural incremental advancement in science from all the evidence that we are putting so much unsustainable pressures on the planet. We're in the Anthropocene, that we face tipping points, and that we can actually define the desired state of the planet to support humanity, namely the Holocene, the extraordinarily stable state we have had of the planet over the past 12,000 years, since we left the last ice age 12,000 years ago. So it was a kind of a combination of scientific advancements that took that incremental step, and the purpose of the planetary boundaries is to protect humanity from crossing tipping points, because when you cross a tipping point, things get irreversible, and irreversibility means that we drift off towards a less and less livable planet. And among those tipping elements, there are only 16 of them, which we have published just before the New York Climate Week. It's in September this year, mapping out the 16 tipping elements. They're actually listed also in the IPCC. One of them is the Greenland ice sheet and the whole polar region, because this is one of the big biophysical climate regulating system on planet Earth. But to come to the Arctic, let me just share with you something that I find very frustrating, that is not well understood. You know, today we can say unequivocally, not only that we're causing climate change, but that every human being on planet Earth is impacted. There's no doubt at all that the most vulnerable communities in the world are impacted most because of the social fragility. But did you know that the ground zero of the most rapid changes on planet Earth is in the Arctic? The Arctic is where things are happening 3 times faster on average, sometimes 4 times faster, as you pointed out, Sally, than the average temperature rise. So, you know, we have so much scientific evidence that we don't want to, under any circumstances, pass the 1.5 degree threshold limit, but the Arctic is already at 3 degrees. Actually, Europe is already at 2 degrees. The Northern Hemisphere has an amplified warming. In the Arctic, this means accelerated loss of sea ice, and it is accelerating. It is a very fast, and it's a non-linear dynamic. But which is undermining the life support for all species in the Arctic, but also for the 4 or 5 million people that make their living in the Arctic. I mean, we tend to forget that this is one more indigenous community that depends on a stable ice sheet in the Arctic. But what I want to share with you is actually coupled to the slide that you showed, Sally, on the arrows between the tipping point systems. Because not only is the Arctic the ground zero, but it's interconnected with the function of the different tipping point systems on planet Earth. So what happens is the following. Our planet is actually a system of biology, chemistry, and physics. And there are 2 thermodynamic engines that are connected to the Arctic. Number 1 is the polar jet stream. The polar jet stream is a river of air that flows from the west to the east, 10 kilometers up in the atmosphere, above the North Pole. It's driven from the gradient of warm air in the equator and cold air in the Arctic. This is a thermodynamic engine. It flows rapid air, which keeps the whole jet stream in a very stable circular form, pushing all the weather systems across the North Atlantic, you know, hitting the UK and basically determining heat waves, rainfall, low pressure, high pressure in the entire part of Europe. Now this thermodynamic engine is slowing down because of the rapid melting of the Arctic, because it's warming so much, so the gradient is weakened. It means that the jet stream starts meandering and you get a lock-in of high and low pressure systems. And we see the impacts. The massive heat waves and burning in Europe that has been happening time and time again is associated to this jet stream lock-in. You may remember the terrible summer in British Columbia last year. 49.6 degrees Celsius and the burning down of the town of Lytton. That was an omega blockage of the jet stream related to the Arctic melting. So you imagine, the Arctic is impacting on a big biophysical, major thermodynamic engine regulating weather across the entire Northern Hemisphere. But the second one, even more dramatic, the one that Sally had on the slide here, is that when the Greenland ice sheet and the Arctic sea ice melts, it releases cold fresh water into the North Atlantic. Well, but that makes a big overturning of heat in the North Atlantic to slow down, because it's another thermodynamic engine, because you have warm saline water flowing from the surface of the Southern Ocean. Saline water is heavy density. It comes up in the North Atlantic, releases heat, which makes it possible to live in my part of the world, in Scandinavia, Gulf Stream. The water sinks and keeps this engine floating. But when cold fresh water dilutes this, the salinity gradient weakens and the engines slow down. And the AMOC has slowed down with 15%. This pushes the monsoon system further south, which can explain why the Amazon rainforest, another tipping point system, is receiving less rainfall and burning faster. But it also means that warm saline water is stuck in the Antarctica, which can explain why the West Antarctic ice shelf is melting faster. So can you imagine? The Arctic is connected via the overturning of heat in the North Atlantic with Antarctica. And what happens in the Arctic impacts on Antarctica. So we're all sitting in this interconnected, complex system where the Arctic is really a ground zero.
Yes, yeah. And it's my understanding that the loss of the sea ice is linked to a wobbly jet stream and linked to, obviously, because of what you just said, the slowing down of the AMOC and the Gulf Stream. Yes.
Yeah, that's right.
Yeah.
These are increasingly scientifically verified linkages.
Yes. Thank you. Thank you very much.